Question number 3.133. What amount of heat will be generated in an electric circuit shown in figure after switch S is shifted from position 1 to position 2? So in this question, a figure is given that comprises of a capacitor and two cells. There is a capacitor of capacitance C and two cells are connected, one of EMF E1, another with EMF E2. Okay. And in this case, here is a switch which is first connected at point 1 and second point is 2. So this question is stating that if this switch shifted from position 1 to position 2, then what amount of heat will be liberated from there? Okay, so look, first we need to check what is the potential difference across this capacitor. So one end is connected with EMF E1, another is connected with EMF E2. So potential difference is E1 minus E2 when switch is at position 1. So first we can calculate energy stored when switch is at 1, first position. So potential difference is epsilon 1 E1 minus E2 and capacitance is C. So this energy is stored by the capacitor U1 is equals to half CV square, that is E1 minus E2 whole square. Okay. Now, when this switch is shifted to position 2, then this cell will not be part of this circuit anymore. Okay. So the energy stored in capacitor will be due to this EMF E1 only. So we can calculate that when switch at position 2, okay, then the energy stored in this capacitor, first we can find out the charge stored in this capacitor. That charge stored would be C into E1, and second, energy stored in this capacitor U2 will be half C into epsilon 1 square. So here we need to check that how much heat is liberated when this switch position is changed. So we can write that change in potential energy plus heat loss must be equals to energy of this cell. The energy of this cell is Q into C2, right? What change is taking place? Q into E2. Okay. Now see, final energy is half C E1 square. Initial energy is half C E1 square minus E2 square. So we can write half C E1 square minus 1 by 2C E1 minus E2 whole square plus heat lost by this system is equals to Q into E2. So this Q is C E1 into E2, right? Now see, if we'll open this bracket, then from here we'll get half C E1 square minus half C E1 square minus half C E2 square plus 2C E1 E2 divided by 2. So this is C E1 E2 plus heat, and that is equals to C E1 E2. So these two terms will get cancelled out. These two terms are eliminated. So from here we can write that heat liberated minus half C E2 square must be equals to 0. So when we'll shift the position of switch from point 1 to point 2, then heat released by this system would be half C E2 square.